BAC is grams per 100 milliliters, right? So we've got a BAC of 6.9. So that would be 0.069 grams per 100 milliliters. Molarity, we're asked to find molarity of ethanol, right? Molarity is moles per liter. So I want to convert grams per 100 to moles per liter. So ethanol is 46 grams per mole, right? I've got 2 carbons, oxygen, and 6 hydrogens. So, all right, for 1 mole of ethanol, 46 grams, right? So 0.69 divided by 46, I've got 0.0015 moles of ethanol per 100 milliliters. But molarity is moles per liter. So in 1,000 milliliters, I have 1 liter. So I'm essentially just multiplying by 10. So 0.015 molar would be the concentration there. 2 significant figures, right? Because of my BAC is 2 significant figures. And again, your numbers might be different, but the steps would be the same. We're just taking that concentration in grams per 100 and converting it into moles per liter. All right, so what's question 23 for people then? If question 21 was the BAC question, what's question 23? Or 22?
For me, it's an enthalpy question where it says 2 aluminum plus 3 halves oxygen.
All right. Yeah, I'm not sure how the numbering got a little bit messed up. So this question right here, I think.
Yeah.
Yep. Right, so we're looking for the overall. So Hess's law again. And let's see, what do we have? So question, reaction 1, aluminum's in the right place. Reaction 2, iron is not in the right place. It needs to be on the other side. So, right, we're going to keep the first reaction as is. So that stays 2 aluminum plus 1.5 oxygen goes to aluminum oxide, and that delta H is going to stay the same, 1675.7. The next one, right, we have to flip that, and so we flip that. Yeah, Zoe, I can go back to 22. We flip that, right? I get iron 3 oxide, breaks down into 2 iron and 3/2 oxygen. I flip that. Delta H becomes a positive 824.2. Add those together, right? That weird 3.5 or 1.5 oxygens cancel out. I'm left with 2 aluminums. Iron 3 oxide yields aluminum 3 oxide and 2 iron. I add those 2 delta H's together and I'm going to get a positive, or sorry, a negative, let's see, 1675.7, 824.2. So I get like a negative 851.5 kilojoules. Decimal. So yeah, I would say there needs to be a decimal. So I'd say like negative 8.515 e to the 2 kilojoules for that question. And then, yeah, the ionic compound question is easy. We can jump through that really quick. Sorry, were you all set with question? The Hess's law question? I'll take that as a yes. Now someone's iPhone is doing homework. That's so the one question that's about an ionic compound for DARA, right? If we have 0.3 molar something, it goes into solution and creates 0.06 and 0.09. We're looking for something like X2, Y3 or X3, Y2, because when that ionizes, we're going to get 2X and 3Y, or we're going to get 3X and 2Y, right? So based on that initial concentration, I'm either multiplying it by 2 or I'm multiplying it by 3. So this first one, right, the strontium phosphate actually fits that. Yeah, Dara asked for the ionic compound one. So strontium phosphate fits that formula, the 3x 2y. So yeah, strontium is going to be 0.09 molar. The phosphate would be 0.06 molar. And then there's one more that fits this formula on the next page as well. Right, the iron phosphate or the iron sulfate also fits that formula because it's a 2-to-3 ratio for that one. Yep,